we look at lines, the first two parent functions on your list of parent functions are the squaring function, y equals x squared. That's an example of something that's called a quadratic function. And we'll be studying those in more detail in a later section. All right. And then the cube function, y equals x cubed, or you could call it the cubing function. Textbooks give things different names, it varies. Okay, so for both of these, I gave you a table of values where I gave you the x values to plug in. I'd left blank the y values for you to calculate and then plot the points and connect the dots. In general, if I don't know what a graph looks like, I find it helpful to plug in a couple negative numbers, 0, and a couple of positive numbers, unless I have some good reason for making some other choices. Notice when we're squaring things, the y values are never negative. It doesn't matter whether I plug in a negative or a positive number. When I square it, it becomes positive. So I get a graph that looks like this. We call this shape a parabola. You'll notice it has some nice symmetry. The left side is just a mirror image of the right side, and that's because when I plugged in -1 and +1, they both square to give me 1. Same thing for -2 and +2, they both square to give me 2. So my parabola is sort of this U-shaped function. This point here, we call that the vertex. And if it's just the basic squaring function, y equals x squared, the vertex is at the origin and it opens up. For the cube function, since this is an odd power of x, the sign is preserved. So when I plug in a negative number and cube it, the y value that I get is negative. Of course, 0 to any power is just going to be 0. And then when I plug in positive numbers, I get something that's positive. So if I look at the right side of this graph, it looks fairly similar to the right side of this graph. It's going up a little bit faster because I'm cubing things. So when I plug in 2, I get 8. Whereas over here, when I plugged in 2, I just got 4. But it's the same basic U shape, but then the left-hand side is an upside-down half of a U instead. All right, now both of these, if you weren't familiar with these and just got these by plotting the points, that's totally fine. But you want to be familiar with these graphs as we move forward so that you're able to, if I say, okay, we're going to work with x squared, you can just say, oh, okay, I'm working with something like that. Okay. Now, that's not to say that we're going to abandon plotting points entirely. It's very useful to know exactly where the vertex is. But if I know the general shape of this graph, just having this point here and this point here are pretty much enough for me to get the basic shape. I know it's got to be a U with this vertex, and this point sort of determines the curvature of that, and then knowing that it's a U shape, that I'm not connecting those points with a straight line, I am able to get things. Okay,